Right, so we are about to start the very last session of the day, apart from the wrap-up session in the big round hall upstairs, which will be immediately after this one. But please give a very warm welcome to Attila.
Thank you. As said, this is the last session of the day, so I will not be showing too much binary dumps. Hopefully that won't melt any gray matter there. But a quick introduction here. So I'm Attila Csipa. Is the mic on? All good? Yeah. All right. I'll try to get a bit closer here, like that. All right. So I'm Attila. I am actually currently working as a partner solutions manager in HP, but prior to that, I was head of software at PulseOn, and there I was developing connected devices, an optical heart rate module, and the device that went with it. As it turns out, there is a lot of knowledge that you can reuse between these two places, so I will be sort of expanding the concept of connected devices here, so ranging all the way from the smallest attached sensors to a large autonomous deployment. I will just file everything under connected devices there. But without further ado, let's get started. So when we talk about connected devices, what do we mean? It's a pretty vague term, I know, but the bottom line is that it is a device that has to work with a certain constraints, whether they are physical, so some are very small, some are very large. There's no, it has to be small definition for it, but usually there is a constraint when it comes to size. That obviously brings along constraint in terms of the power envelope, everything that we can use in there, and all that. And the biggest or the most important aspect of connected devices is obviously connectivity. So, what are our limits there? So what is the constraint in terms of the bandwidth? So, do we have a fat pipe there that brings us all those megabits of connectivity that we need to relay our data? Or is it something that is really more of a droplet that we can every now and then send a little ping? So different channels have, of course, different characteristics. The connection can be over Bluetooth, it can be over Wi-Fi, Ethernet, you name it. But it's really a wide range. So it depends on your application, how much data you want or need to push through all these. So let's take one end of the spectrum. So how many of you are interested in the wearables side of connected devices? Okay. The rest of you is more embedded or in general, or is it PC or beyond? Okay. So when it comes to wearable devices, they have a very strict set or even more limitations that we would think for smaller embedded stuff, right? So they have to be small enough that we can wear them. They have to be appropriate for the location, and that just brings along a whole set of things you need to worry about. So in our case, the demo device that I will be referring to is a PulseOn heart rate module device. So it's this guy here. So it's an actual real device. It has been built, works. You can actually buy it today. So it's a real thing. And while it itself doesn't really run Qt, that Cortex M3 unfortunately is a showstopper there, but it does help a whole lot in the battery life and the sort of the autonomous operation of the device quite a bit. On the other side of the fence, what we communicate to the companion application, that's where we use Qt extensively. So what it's good for is autonomous data collection. So you put it on your arm, of course, and then with the science behind it, it illuminates the skin, reads the results, and then you can deduce the heart rate from it. We do a very basic algorithm on the device itself, but then we transfer as much of the data as we can to the other side, whether that be a phone or an embedded device specially designed for this purpose, and there where we process or do heavy lifting, and we can do far more accurate readings. So that's what happens on the back end. It's also good to know that this is the spot where you want to take care of all the things like analytics and crash reporting. So this device also crashes. It runs an operating system of its own, FreeRTOS, whatever. So there you will be having reports from there. You will be having crashes of your own application or companion application, whether it runs on Android, whether it runs on iOS, or even just a Linux application or a Raspberry Pi. So there will be that as well. And you want to just gain as much insight on how your users use your applications and device or whatever you are providing as a service in the end, so that you can tailor and tweak it so it works even better in the future. So that's one side of the spectrum for connected devices. The other side is, this is a basically a PC with a whole lot of extras thrown in. So you can actually see one upstairs in the exhibition area. If you haven't yet, then after this session is a good time probably to take a good look before we pack it away. It's a PC, but it comes with a sensor array, so it has a bunch of cameras on top, does 3D scanning, it does object recognition, OCR, so automated processing and all that stuff. And it's quite often used in kiosk scenarios. So, it's left at the mercy of bystanders, basically. So the mat is very resistant, so it can take a lot of physical abuse, but of course you want to know what's going on. So what are people doing with it? And if the software crashes, then you want to have, of course, good information of what has happened and how you got there, right? So it's a very different type of connected device. So it is a Windows 10, but again, the connectivity is very intermittent. You don't know where it is, so it's not that it's just in some office that that has very good internet connection. It's probably in a store, or at an airport, or in a hotel lobby or somewhere. So there is a lot of challenges which you need to accommodate when you want to relay information back from these. Same here, that again, we want to know everything in terms of what people did to it and how they did it, and if there was a malfunction or a crash, then that what exactly happened there. So the general considerations about all these things about crash reporting and analytics that we wanted to have is that, on one, because we use Qt extensively, both on the middleware side with C++ and also on the UI side with QML, we wanted to have reports for both sides. So it wasn't really an option to go for a pure C++ solution or only QML. We really wanted to have the whole range covered so that we can track or pinpoint all the individual problems throughout the application, regardless of where they were. We didn't want to include third-party applications or SDKs. So putting in just a full Google Analytics or Crashlytics or SDK in there is really not an option. So RESTful APIs are a bit better in the sense that we have a very clear line of where our stuff ends and where the other side begins. So we know the obligations and what we are committing to when we say that we make a call to the other side. Whereas if we have random code running within our applications or devices, then it gets a lot murkier. So this was a limit that we don't want to go including other people's SDKs. And finally, you do need to take care about privacy and encryption. So this is data of people you are sending through. So whether it's a crash or something, it might include data that is belonging to someone, personal data, etc. So be very careful when transmitting this stuff across the air, right? You don't know what channels it's going through often. So the internet is not really a safe place. So at the very minimum, use HTTPS and the valid one, not self-signed certificates and all, but like how it should be used. And of course, have your policies straight so that the users know that they are being sort of logged or their behavior is being logged. So that's very important. One thing I forgot to mention here is the support for native code. And I highlighted this for a reason here, because often when I ask people like, oh, we have a crash reporting SDK or some analytics software, and like, do you support native code with embedded platforms and stuff? Yeah, we do Java. Like, whoa, I mean, like really native, like, not Android Java native, but like the C code. So we often work at Bluetooth level, etc. So when we crash, then it's really low. So we want to have a detailed information of that rather than just, getting an error at the JNI level that, hey, something went wrong in your native code. So that all these things sort of were targets that we need to have these so that we have proper crash reporting analytics and, do that right in Qt. So for the crash reporting part, we actually went with CoffeeCatch. It's not a universal solution, so you will not have, I don't think there is any sort of even close solution that will cover all the platforms that Qt supports. So they are really, really sort of across the board in that regard. But since we had to support Linux, basically, and well, so let's say that we were okay with POSIX in general. So POSIX compliant operating systems were okay. CoffeeCatch actually works pretty well with that. It was primarily meant to work with Android, but it works as well with iOS. You can even use it in Windows, etc. So it's a pretty universal thing. But I'm sure that there are operating systems which are not POSIX enough for that to work. The trick with CoffeeCatch is that it actually maps signals like segfault and such as exceptions, and Qt doesn't really care about exceptions, so they just go through. So Qt internally doesn't use any exceptions that you as a developer would see. So it's a good thing that we kind of can catch these from the outside. So normally a CoffeeCatch application looks something like this. There is basically a try catch and section there, and it's pretty standard, so there is nothing magical here. It's, if you ever did a try-catch, you saw something like this. And it was quite easy to integrate that with Qt. So you basically just have your main loop started in the try part of the thing, and then pretty much you catch whatever falls out if it's an error. So this will catch, of course, I said, segmentation faults and everything else. So it's pretty good, or term signals, whatever you might encounter. And then, of course, when you catch it, then you need to process it. So then that's when you deal with whatever you want. Now, note that this is a place where you're in trouble. So when you get to your catch statement, then you know that you're already dead. So, your application terminated with a very nasty cause. So whether it was out of memory, whether it was a sec fault, a bad pointer, division by 0, something, whatever, but you know that the application is pretty much dead at this point. So you have to be very careful, what to do at this point. So can you, it's like, well, I'm going to open the browser. No, you don't open browsers at that point. So you're dead. So it's like really, really, if you can write something to the hard drive or the flash, you are super happy that, I'm at that level of alive still. So, keep in mind that at that point you are in deep trouble, or your application is in deep trouble. So, normally I would, as I said, if it's connected devices, you have basically two options. One is relay that through the network and hope that, again, there is enough functionality that you can do that. And second, what has proven far more reliable is to just write to the flash. And, that's it, just a simple stack trace to the flash, and as much information as can be included at that point to the trace, or the state of the application, right? So what happened when we did this? So go ahead.
Where does the coffee come from?
The CoffeeCatch in the name? To be honest, I don't know.
Not the name, but I'm pretty sure if I used my project, it wouldn't find such macros like you used in. Okay.
It's literally include CoffeeCatch.h. Yes, so you download it from there. It's a CPP and an H, and then you're done. Sorry, yes, I didn't sort of show that there, but the code is basically there at the GitHub location, and you just drop these 2 or 3 files in your project, and then that's all the enablement it takes.
Is this well known? I mean, did you also compare with Google Breakbat, for example?
Yes. So with Google Breakbat, it wasn't as generic. So you can do a lot of things with Google Breakbat as well. I used it. So for some things it's okay, but when it came to this really low-level debugging that we did with, especially with the Bluetooth stuff, that sort of unfortunately didn't work for us. So that was the problem with Breakbat specifically. Otherwise, there's a whole range of solutions that, of course, try, and usually the thing is that they come from specific clients or needs. So they address one problem really well, or one layer of or type of crashes really well. But then when it gets more universal of what kind of crashes do you want to catch, then it different ones have different sort of advantages and disadvantages. Okay. So in our case, what proved to be the winning strategy was the store and relay approach. So this means that when you had a crash, then you save it. That's something that has been sort of pretty okay or pretty successful, and then you just exit. That's it. So I try to mitigate. If you can put a sorry we crashed or something, then that's good. If not, then just close. So go away. And the sort of the magic happens on the next startup, really. So what we do on the next startup is we detect if the last time when we crashed, or the last time that we sort of started the application ended with a crash or exited cleanly. So if there is something that we have written there with the crash trace, then obviously we have not lived up to the expectation and crashed somewhere. And we enter a sort of a little safe mode there. So what we try to do is then we try to relay, because now we have a clean slate. The application is just starting up. We have a clean slate, so we start and relay all that information back. So what we do is that we relay all the saved crashes that we have. There can be multiple, so this can accumulate, and then the crash itself can be fairly large depending on all the information you want to send back. And when you're done, when you know that you succeeded, then you delete the log and delete the save flag, and you're off. Now the thing is that what we do is just to avoid, because this, as I said, is done through some links which are really, really slow. So we don't want to leave people waiting for too long that, hey, I need to upload my crash report, and it's because it's a 10 meg file, then it's going to take about 4 hours. I'll come back then to our kiosk. In 4 hours, it's going to be awesome. So what we do is that we do this asynchronously. So when we start the application, the actual crash upload is happening in the background while the application has loaded. So as a user, you don't really see this. Obviously, the danger is that you can crash multiple times in a row. So in this case, we would just append these to the end. Now, that's why I put in there, so if we start up and see that the previous start was also a crash, then what we do is then we stop and say that, okay, so first we upload the crash report because we know that we didn't manage even to finish uploading the previous one when we crashed again. So it might be that it's the initialization or something very early on in the application that is catching this. So, be aware how long it takes to update these reports or upload these reports, and that, that might interfere with the user interaction. So, be mindful of how you treat the user, or tell them if you want to tell them that, the previous time we crashed. So in kiosk, that's not really important because, it's going to be probably a different person that's using the kiosk again. And that's sort of what we do now. So most of the action happens on the following startup after the crash. And how does one of these look like? So if without too much effort, if we don't try to debug too much, and I said it's a session which is now it's like 3:45 already, so I don't want to show you too many dumps, but the idea is this is what you get, like a normal trace. Now, of course, there is some information in there. You can get some naming of the functions, etc. But this is more into how you distributed your file. So are you able to distribute debug builds? Most of the times the crashes will be, of course, done by release builds. So you don't put debug stuff on end users' devices. So, but don't ever kind of just ship the release executable and then delete the build. So if you are building on Jenkins or doing something, always with a release build, make also in parallel or keep at least the build that you have with the debug info. So in release mode, but with the debug info, and keep a copy of that. So that's going to be super useful because when these things come back with the hex codes for the locations, then that's the only way you can actually refer to a specific point there and not just kind of, well, in some dysfunction or area of the code roughly. So it's also a thing that, you should try out your crashes first. So, put in a 1x0 somewhere in your code, or do an intentional pointer dereference and then check out the whole cycle, whether it works. So don't just rely on, well, we have something crashing and now we put in and we try to actually find that. So, work your way through, verify your whole procedure in terms of the crash reporting first, and then start catching the bugs. So that's a hard lesson sometimes. Now, there is a certain subset of these which is especially tricky. And that is the unfortunate thing, that what happens when, for example, you have a hybrid code, not that rare nowadays, when part of your application is in C++ and part of it is in QML. So let's say you have a property or something and you use it from QML, and it turns out that your destructors or just memory management is not up to scratch, and your object somehow manages to die or get deleted along the way, and then you refer to it from QML. So then you see something like this, and it's like completely useless. Because what you see is a crash in QtQML. It's not really a crash. It's basically you passed in an invalid pointer somewhere, and then of course it just kind of, that whole chain reaction brought down the application on its own. So what you can do is, in this case, is that you have to do it on the C++ side. So unfortunately, this is really not helpful. This is something that you need to take care of on your C++ code, whether that be auto tests or something else. But at this point, you will not be able to come back and say what has actually caused the crash. So be aware that your exposed C++ parts need to be super clear as what do they expose, and your objects, their lifecycle management needs to be super clear, because these will be a hell to come to, sort of these errors will be really hell to hunt down. And once you have those reports, so and if they are in your own code, then you can use, of course, the standard tooling, readelf, adder to line, or any others to actually go back into the exact line of the crash that happened. Now, the exact line is only available if you actually have the debug info. Otherwise, you'll just see the name. You can demangle the name, but you won't see the line there. And an important note, again, learning the hard way, always use the toolchain for the right platform. So on Linux, you will probably have, if you have binutils, you will have this function, and you can call it from anywhere. But it doesn't mean that it has all the ELF binary support for everything. So if you are debugging Android binaries, you might want to use the Android version of this or the build that has been done with that particular platform in mind. Otherwise, different compilers, and you get all sorts of nasty things, and you don't even know what's kind of causing. Why am I not seeing the function names or something there? You will get just question marks there. So always make sure to use the right platform. ATOS is the same thing for iOS. Basically, just matches the address in the binary to a certain source position. Any questions? Okay.
They maybe just freeze. So have you added some mechanism to detect such scenarios and where it's actually freezed? Yeah.
We are getting to the next section, which is about analytics, and that's a lot closer to that. So a crash reporting is what the name implies. There is a crash, and we want to report it, right? So freeze is basically just unexpected behavior, probably unintended, but it's doing what you said it to do, right? So you will want to hunt down what are the causes, so the analytics proves or gives you at least some insight on what might be causing it, right? So you might be wanting to time the sessions or do something or like certain parameters of your application at runtime so that you can lead up what's happening up to that point. Usually, when you have this point of freeze, it's already very difficult to say. You maybe, if it's due to, let's say, the use of memory or something, then you might be able to see through a profiler that, oh, by the way, this has ballooned, or this variable or this part has ballooned to so much. But if there is something else, then it's going to be really hard to say unless you see how it built up. So wherever you were leaking memory, it's like, oh, I leaked, a gig of memory, but I don't know where. At the point where I know that I have lost so much, it's already too late. So I cannot go back and say like, oh, now I will check back where I lost it, right? So that unless you're doing Valgrind or something like that, but that's not again something you can do on an end user device, right? But let's get on to the analytics part of that, and then it will become a bit easier. Or a question before that, yes.
Do you sometimes want to see where a warning happened? For example, some problems happened only in the wild, and you don't know actually why a certain method, on a certain code path of method got called, and in which runs.
Yeah. So you do get a trace, so which should give you a call path.
Of course, but you don't want it to crash in order to have the stack. So could you also stimulate it just as you would run with an assert in a debug build?
Yes. So definitely. So obviously, this is what I get in my mailboxes. That hope that's it. So of course you can append any kind of text message there. So you can say that if I'm still alive and well in my application, I can still unwind the stack and see where I'm currently at this moment, or record certain variables or their state, just kind of as a reference point, and you can write that and use the exact same mechanism as you use for the crash reporting to send it back home, whether by email. If there is more of it, so crashes are not that common, so you can usually get away by either sending an email or just a single HTTP request. But if there is something that is a very common call, like a function call, and then you do it like 100 times a second, then you probably don't want to send emails with every call. So obviously some trade-offs must be made in terms of the mechanism of delivery of state of application. Oops. Yep, go ahead. Yep.
In some application, in embedded system, it is necessary to stop everything and show a specific message to the user with sound, light, etc. And be sure that no one overwrite this message on the graphical user interface. How to do this?
Right. Well, I'm not sure that it's along the lines of crash reporting, but that really depends on the platform, right? How do they handle, for example, model dialogues and such, right? So Windows is fairly clear on if I pop up a model window, then you're not going away. So that has to be poked before you can do anything else. If you're on an embedded device, then it's really up to you, right? So it depends on what sort of how do you use the interface. So. Right. So, well, that's a different thing. So that's something that was similar there in the beginning. So there are some ways of, let's say, temporarily freezing Qt, but it's not really that you can just pull the brake and say that everybody stop right now and until I do anything else. So nowadays systems are far more complex than that. What you can do is things like stop the event loop so that no further events will get processed. It's also evil, so be very careful when you do things like that. But at least it will not keep on doing things in the background or continue forward until you do whatever you need to do to resolve either another pop-up or some system level stuff. So, but in general, there is no simple way of freezing the application. And the other question is, do you want to do that from within the application or from outside? Because if you are so the thing is that you can stop the process, so which pretty much freezes everything, right? So that's sort of the easier way, or pretty rough, I admit, but the easy way of stopping that, and you can of course then send the resume signal and then continue where you left off. But again, you would have to know the exact operating system and what you're using in terms of how feasible that is. And okay, so now on to the second part of this, the analytics part. And rule number one, right? Whenever it comes to analytics, don't be evil. So I don't think people realize they don't want to be evil, but then they kind of end up being that. So you are collecting, as I said, people's data there. So it's probably the most valuable thing. They probably value that data more than you value your application. So don't bring yourself into a position where you say, well, I went the best with that. I just wanted to collect some data because I want to improve and whatever. So make it super clear what the data is used for and how you use it. So no personal identifiers, whatever. Anonymize as much as you can and really focus on the things you want to do with that data. So be super clear on what you do. And the other thing is that okay, you're not evil, but don't enable others to be evil either. So as said, if you are, for example, not using HTTPS, just plain HTTP, then you might not be doing the wrong thing, but the guy who's listening to that traffic is free to do pretty much whatever they want. So be very careful with what you send home, and when you call home, then the information that is sent is at that level, really the bare minimum needed, and that it doesn't link back to users unless they really that's the intended way of doing it. Okay, so with that warning up ahead, now we can see what we actually use analytics for, like the real white hat cases. So we can see a number of things. So starting with the usage, how often do they start something on the device, how they move between the individual pages or stages or states of the application, where they exit the application, where do they leave. This is also important, especially in mobile. Do you have an interface, and then where did they leave? Where did they get bored? So that kind of thing is also very useful information. And this part there for the question of performance, that's also that you can start doing timings, memory footprint, all that stuff, and you can log that. So you can see whether you are leaking memory over time, what's your startup time, for example, on the type of device, etc. So all these things are really useful for the analytics perspective, and it also allows you to track these changes over time. So you start with a premise, and it works. My application starts in 5 seconds, and then you add stuff, and like somebody comes back to you 6 months later and says like, oh, this slow application, and like, how do you mean slow? It just starts up in 5 seconds, and have you tried it recently? And then you look and you see that on the client devices, it turns out that it takes half a minute now because you added so much stuff in the meantime that suddenly the startup time has crept up to something far more. So this allows you, with the proper analytics, to track what exactly is going on and how you are evolving. This is especially important if you are not on your own hardware. So, when you actually make the device, then it's kind of easy, okay. But if you're running on a mobile phone or something, a very small embedded board, which is coming from somebody else, then you don't necessarily control the amount of CPU and stuff that you have at hand. So it's really good to know, what things are people using your software on. Any other ideas why we would be wanting to use analytics? Okay. Marketing information, yes. Again, with the don't be evil premise there, that we don't want to go too deep in their personal lives and whatnot. So if it's useful, if it's for yourself, yes, but please don't sell information. That's like pretty low on the bottom feeder scale there. Okay. Why would we want to use it? So I think it's time for like the comic relief part of the session. So, well, turns out that your internal tests might not be representative. So the way you click through things, and I think that the user does this, 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 and this, and it always works for me when I do that. And it turns out that the users don't do that. So they do something else. So you take your device and use it in ways you didn't expect. They press where you didn't expect. They press in the order you didn't expect. So analytics is super useful in figuring out in which way are people actually using your application. It turns out that as intuitive as we think we make our software, users don't really always feel the same way, right? The other reason why things might go wrong and where analytics is super, super useful is that large-scale deployments are tricky. So, it worked for me when I was doing my deployment with one device, but when I rolled it out to 100,000, then suddenly things went wrong. So it's really hard to test or predict what's going to happen when you kind of try to scale up, right? So we have an idea. It's easier if you didn't done something like that previously, but usually it's very, very hard to predict, just how your application will scale when a larger number of users start to use it. So this is a problem most typically found on mobile because, on Android, when you publish it, then there is 1,000 downloads, and then suddenly that, 1 second processing time, well, that's not that bad, and it becomes a minute. So it kind of grows very easily, and analytics can immediately show you the dependence between the number of users and the load of your system. And another thing, second chances are rare. So it is a tough world. So users are not really too forgiving, unfortunately. So we need to get things right. And if there is something going amiss, we need to know it quick, right? So if there is a crash happening, if there is a slowness in the system, freezes, whatever, then I cannot wait for 10 people to come to me and tell, oh, by the way, your thing freezes or crashes or whatever. I need to know it as soon as it happens so I can fix it immediately. Because if everybody knows that it's bad, then sorry, there is no second chance for that. So it's a very unforgiving environment, unfortunately, especially if you are in the mobile side of things, because then it's well, take a look at any of the comments, I believe, on the stores, and then you'll see that how unforgiving that environment is, right? So you have to be very, very careful there. So what did we use in the end? So it's a bit of a compromise, I will admit. We did use Google Analytics measurement protocol, emphasis measurement protocol. So we didn't use the Google Analytics SDK. We just used the stressful API, which is used then to basically just fill in the data, and then you can do the standard Google Analytics inquiries or maps and everything that come with it. But we don't provide any user ID for it or anything of the sorts. So it's really just using the protocol. And the reason we went for this was that, one, it has no SDK dependency. So we really just make HTTP request. And when I say HTTP, I of course mean HTTPS by that. And again, that allows us to have no platform dependency, right? So if any platform can make web requests, that's pretty easy. So even if you don't have a specific thing, or if you're not using Qt network or something of the sorts, you can always just open a socket and write the stuff in. So it's not that difficult. Web stuff is also doable through both C++ and QML, so no problems there. And an important thing there, especially if you're using Qt network, this is nifty that a side effect that you get, that this is we need it to be non-blocking. So when we do analytics, again, with the same as with crash reporting, like don't let analytics get in the way. If you do it too much, there is too much traffic going on, and you are holding up either the speed of the service, the video playback, or whatever is happening on the other side, then your analytics approach is wrong. So it should be really just a very, very thin layer with provided the absolute minimum data that you can work on. So don't overload it with data that you have 1,000 requests per second coming in from a single user just because you want to have a feedback on every pixel that is being drawn, right? And we, of course, the other thing that we wanted to do is to have offline support. So, for example, when you use devices like this, what happens that often is that people move out of radio coverage. So whether because they are either running indoors or through a tunnel or something, or there is just simply, they turn their data off, they don't want to be called, they put on airplane mode, whatever. So there is a lot of scenarios where you just don't have network connectivity all the time. And for kiosks, this is true as well, because often there's interruptions, breakages. It gets back after a while, of course, but not all the time. So we wanted to have offline support, and we actually did that. So I will get into it. So I will show you code, even though it's pretty late now. though I'm going to break my neck because I will have to, no, the other way, no. How many windows are there? Let's try and find the window that my Qt creator is on. Or just do that. Okay, can you see this? All good? Okay, so there you go. I went with the rather uninventive name of Google Measurement Protocol, and that's the reason why I didn't publish it, because obviously I cannot use the name Google on GitHub or any of the places. So as soon as that gets sorted, this will end up on GitHub. And this is how it looks like. So what we start off with is, well, you can see that there is a number of properties. This is to make it more available through QML, and you will see down here that there is a number of invocables which also serve as a way to communicate through QML as well as C++. So what happens here is this is really just a C++ class which wraps HTTPS requests and then sends those off. It also buffers them. So for this case of offline scenarios, it just saves them locally so that the HTTP requests are saved, and then when the network connection is reestablished, then it sends it. The measurement protocol actually has a flag which tells you how old the data is, which you should use, otherwise it will discard it. It will say, this is too old, I don't care about it. So I know when I'm sending it, and I know when I created it, so therefore I can send it and still produce meaningful data. So I can start my session, get when my application was started, get functions like what's the user agent, this tells me what device I'm running on if I don't know that, if it's a mobile deployment or such. I can report my exceptions, or like if I do that internally, or if there are any in QML. And of course, since I wanted this to be somewhat universal, I actually used the version name and ID that I would for the Q application. And of course, these are the ones, if you're familiar with Google Management Protocol, then these will sound familiar because these are really just wrapped calls for the REST APIs they have for these. So this is a stuff that they normally use. Now, I use it maybe a bit differently. So for example, show screen is originally meant to be web pages, right? So their own SDK or Android pages. Now this does not necessarily cover everybody's use case. So you might have just one screen or something. So I give you the freedom. This is just a Q string. You can put pretty much anything in there. So if you have overlays or whatever, you name them differently. If you have tabs, you use tabs for this purpose. So it doesn't really matter. And there is a number of these which are for timing. So I help you a bit with timing so that when you want to report how long something took, whether it's your internal processing, how long it took to download something, to generate something, to produce something, but also for the user. This is the other thing, that you want to time the user as well. How much time it takes for the user to do something, to complete something. That gives you an insight on how much, how intuitive your interfaces are. If everybody takes 15 plus minutes to go to 3 pages, then your interaction designer is probably also ripe for some change or needs to work on his skills, right? So that's also something that is useful, not just for the state of the application, but also the user. And then, of course, you can report individual events. Something happened. I had a conversion. Somebody bought something that is relevant to whatever the application is performing at the moment. So with these, you can pretty much expose a very good part of the Google Measurement Protocol, which then gives you a good insight on actually what's going on in your application. This is actually a singleton, so there is some extra magic down here. You shouldn't have this in the H file. I just put it here so that I can show it without switching files. And I guess this mutex locks means that Bo Thorsen will probably punish me with invoices because he said never to use qmutex. Anyhow, to continue with what this is good for, what this does is it allows me to do things like this. So why this is a Qt session in the first place? So yes, you can write a C++ class that wraps HTTP calls, big deal. But what makes this really convenient is that you can hook now these, because these are also signals and slot compliant or compatible, that you can do things like this. So for example, when I flash my device, I will send home a little event or message that says, hey, the device has been flashed. So I know how many people flash their devices or how long it takes, for example, between the release of the flash or the image and the actual flashing. So do people upgrade immediately? Does that happen? And I could have the same for failures. So I can track the ratio of success versus failure or what the failure reason is. So it's actually pretty easy. And you can pepper your code with these as much as you want. So these are signals and slots, so you don't need to worry. It's not a synchronous thing. It will get sent at some point when there is enough bandwidth. It will get logged if you are offline, so that's perfectly fine. And this is how it's exposed to QML. So basically, there is a single instance, so it's a singleton. There is no point in having several objects of this. So it's just a one there that is as important. And with the register singleton type, I can expose it to QML. So when you do use QML, this is how that looks like. Also super simple. So you just say, my analytics says I have shown the screen home. That's it. And you can use the same thing for report event and everything else. So whatever you put, whether on the C++ side, link to signals, manually invoked, or you put it in your QML code, and that you always get all these events back. So it's a very nifty way of just giving your users some input. What I would like to show you is what this generates. And this is the good stuff. This is a demo set of data, so don't worry. I'm not showing anybody's nasty stuff here. So you would get something like this back. And this is the good thing, that by using the Google Analytics Measurement Protocol, you also get the good stuff that Google does for you. So the geolocation, the referencing, the language, all that stuff is sort of for free, right? So because of the request that we made. And since we simulate the user agent with the device, we can also create types of devices. These don't need to be real devices. So I could make up my own kind of codes there. I just said that, okay, so if it's an Android device, obviously I will send the name of it, but I could use my revision 1 board, revision 2 board, etc. So I would know which hardware, and then I could filter for it. So you can use all the filters and use cases and everything. And to make it even better, if my demo is good, there we go. So that's what's happening. So where are users using my application right now? This is super useful. So I said you get this for free. So you just included a little CPP file and peppered it with a couple of report event, and you can, on my screen it looks a lot better. The contrast is a bit better. I don't know if you can see it. I will zoom in on Europe maybe, then it's more visible that this is actually a map, or not. For example, this is Finland. I don't know if you can see it, Scandinavia. So I have a test user who is now using my application, and I can see that he's active right now in Finland. And you can see that, for example, where are they? So they are on the home page right now. So you can gain a lot of insight. And I will, again, repeat my start with the analytics. Don't be evil. So you can track a whole lot of things. So be careful of what you log and why you log, so that other people don't get confused and misinterpret what you are actually doing and what you are using this for. And you can also, use all the good things that are here, and that's why we went with this stuff. So, any questions regarding analytics? Yes.
How did you get around Google Analytics spam?
Sorry.
How did you get around Google Analytics spam?
Spam as in. Right. So that is one of the downsides. So the thing there is that, so usually the random spammers, like I use, for example, a user agent string, which is specific enough for me that I know that anybody who called in and is not using my own. So for example, I always relay back my app version. So I know that if somebody came in and they didn't have an app version, which is this, or this, or app name that is this or this, I don't care. So I can filter for that. So that's the easiest way. There was somebody there, yes?
Yeah, you told that you use an own implementation and not the original Google Analytics, but you showed the page from Google.
Right. So
do you receive a file that you upload to the page, or how does it work?
No, this directly uploads so it makes HTTP requests to the Google servers. I don't use their SDK. So there is no pre-processing anyway. I just use the RESTful API. So there is different ways of calling. They have an iOS SDK, they have an Android SDK, and for sort of everybody else, they have the RESTful API. I also use this on Android, but it's more universal this way. And as I said, it's a lot clearer as to what code is being included. There is also implications in terms of licensing and everything that I can use if I include other people's SDKs. So this is easier this way. But as I said, we just use the Google service to visualize, and you get these things for nifty for free in terms of like geolocation and stuff. There was somebody there, yes.
The customers are mostly paranoid. How do you convince them to allow you to get this data?
Right, so they usually are, and most of the time, unfortunately, rightfully. So most of the people are really bad at storing this data or kind of giving it a good protection, right? So step one, so like what you need to do in any case is to make them aware that this is happening. So it shouldn't be 5 pages down in a 100-page license agreement that there is something hidden away, so that it's clear that this is happening. And two, if it's appropriate, then let them opt out. So there is nothing preventing you to turn this off and say that it's not compulsory. So it's a trade-off. Some people will say that we don't want to include anything. That's fine too. But as said, no second chances. So you really want to have that information. And of course, you decide how deep you want to go. So you could, if the application has access to personal data, age, gender, whatever, then of course, that's very good for marketing purposes. But then there is this ramification of, people really don't like that being sent over. So you have to make your own trade-off. So to be honest, people won't believe you whatever you say. You can say, I swear that I will not misuse this data. I say, yeah. So it's just the way it is. So you have to sort of build a track record and say that this is going to be the real.
Yeah, I understand this, but well, for example, they believe me, but they don't believe the subparts I use.
Okay.
Okay, so
Surely it's the same trade-off. You have to accept if you use Google Analytics as a service, people have to trust that service.
Right. And to be honest, to be clear, so what I'm doing here, these are HTTP requests. I don't have to send those to Google, right? So I could mirror the exact same interface on my servers and send that data back to me. I don't get the nifty visualization in that case, or would have to write it myself, but there is no need to send this to Google. I used it just to show it on the map and that sort of stuff. But if you have enough capacity to implement your own sort of analytics and database for everything, then you can send these exact requests to yourself. It's just interoperability.
What was the most interesting conclusion which you've drawn out of some analytics, some real live?
That's, I believe, I don't know if we have time for it, but so. Probably it's faster if I show it like this. I actually had a session yesterday, and there was this thing here, which I believe will tell you what was this thing here. So when we were building this device, we did our homework and figured out, yes, this is something runners buy. Most runners are female. Every agency will tell you this who does market research. Most populous age group, 25 to 35. That's also correct. They also spend most on accessories, and you know that Android devices have 80% market share. That's super simple. So you know your target group, right? So we added the analytics there, and what we found out was that 70% of our users are male. Average age is, or median age is 43 years. And we have more iOS users than Android. So that's why I say that, this is really useful data. So it doesn't really, it's a different thing that somebody tells you generic information that a certain target group likes this or certain target groups like that. But we actually know, what's on the ground, who is wearing these. And that gives us a lot more insight into how we need to develop the product, how we want to advertise it and everything else than any sort of random or generic advice you might have gotten from any sales team or marketing agency.
You said you store. you said you store stuff on the local system when you don't have a network connection.
Yes.
How do you store it, and when? Like for how long do you store it and send it off later?
Right. So I don't have a time limit. I use a circular buffer for size. So I preset, depending on the project or device, I set 10K or 1 megabyte of buffer, and I add on top. And then when I sort of go over that, then I just kind of circulate and lose the oldest, and then just keep the size. And again, the storage depends really on the device. So I sometimes use just a simple file, like literally a file-based thing for embedded. That's the easiest. But then, of course, if you want something more, or if it's a desktop system or somewhere that others can read that too, then of course you either encrypt it or do something. Again, with this remark that your options are really limited. So you cannot call cloud services or whatever. All right. Any more questions? No. Okay. Well, in that case, thank you for your time, and hopefully this wasn't the too hard last session of the day. And thanks, everyone.
Thank you very much.